This past summer, Ohio State announced the launch of a new National Science Foundation Engineering Research Center. It's called HAMMER, short for Hybrid Autonomous Manufacturing Moving from Evolution to Revolution. Ohio State's partners in this endeavor include 4 academic institutions and more than 70 industry, educational, and technical organization collaborators. The center will develop and deploy revolutionary intelligent autonomous manufacturing systems while educating the future manufacturing workforce. Blending the agility of artisans and the reproducibility of machines, HAMMER has the potential to create more robust local supply chains, lower manufacturing's carbon footprint, and create new economic opportunities. Today we're joined by Glenn Daehn, director of HAMMER. Glenn has been a professor of metallurgical engineering here at Ohio State for nearly 35 years. The founder and past director of the Ohio Manufacturing Institute, his research, education, and service efforts are all broadly related to the interwoven themes of a Midwestern manufacturing revival. Welcome, Glenn.
Morning, Dean Howard. It's great to be here.
So before we pound out what HAMMER will do, you get that?
Okay. I get it.
So
Good fun.
Let's frame the challenges and issues that we face today in U.S. manufacturing.
Yeah, so what's happened over the past few years, a few decades really, is we've had a lot of offshoring. And if you look at things like supply chain and balance of trade, we're at sort of a balance of trade that's nearing about $800 billion a year. We are exporting more than we're importing to that level. These are big numbers. These are numbers that are like the GDP of Switzerland. It's bigger than the earnings of 2 of the biggest companies combined, of like I think Apple and Walmart together. You take their sales, that's smaller than that. And economists will tell you that's not such a big deal. There are ways our economy can do just fine with that. But the place that it really falls down is if you don't have today's technologies, you can't really innovate tomorrow's technologies. It's really all based on manufacturing. Some of the things that we're leaning into are really structural components, things that are the basis of our infrastructure, things that are the basis of the airplanes and ships and all of that. And these are parts you don't often think about. They're not things that are typically very sexy, but they're really, really important. And back in the early part of this year, Department of Defense put out a supply chain report. And they found that there were 4 areas that we had really strong defense vulnerabilities. And forgings and castings were among the 4, and the others are ones we've all heard about: hypersonics, chips, batteries. These are the other 3, and then forgings and castings are on there. And right now, almost all of our large castings, things for like infrastructure scale castings, might go for offshore wind turbines or hydroelectric dams. They're imported from China or India, and we're not making them so much here. And then China's also making about 4 times the volume of castings and forgings than we are here. We want to bring that back. We want to bring new technology to that and make it so that the components are better, cheaper, and more accessible, and we have a more robust supply chain here. So these really are all about first order issues of American economic security and supply chain robustness. That's really what we're doing. That's the big issue.
So you mentioned supply chain issues, defense vulnerabilities, imbalances between exporting and importing, and you also mentioned the economists say it's not a problem, but we're engineers here.
We're engineers, right.
And so given that, with HAMMER, how are you addressing these challenges? Okay,
so the things we're doing is we're really going after really new technology with this. So what we're doing is what we call hybrid autonomous manufacturing. And let me unpack what that means. So hybrid means we're using all the tools in the toolbox. Additive manufacturing is a great technique, but it's not the only way to make something. We've thought, there's companies like Relativity Space out there that are trying to 3D print an entire rocket, and I think that's a great idea in principle. But you don't want to not do something where it makes sense to use an extrusion or use an additional part or make something through weldments. And what we're doing is really using all the tools in the toolbox. Imagine you can make a preform by welding up components. Take that thing and forge it, then machine it for precise dimensions. That's the sort of thing we mean by hybrid, is taking all the tools, all the processes that we have, and using those to make a part. Autonomous, what that means is eventually we want these systems to be so that they are autonomous. They're robot-like. So imagine a robot blacksmith. And what a robot blacksmith can do, it has better vision than a human. It's way stronger than a human. It can actually interpret signals. It can measure temperature and make corrections in such a way that that a human can't. And that's where we want to go, is really make this system of hybrid autonomous manufacturing. And this is a big 10-year sort of project. It's not something that we can pull off in the near term, but that's why it's a big National Science Foundation Engineering Research Center.
So hybrid autonomous manufacturing. And you mentioned the autonomous is robot-like and better, faster, stronger. And so if you think about this, artificial intelligence also plays a role in this hybrid autonomous manufacturing. And I don't think a lot of people realize that AI, artificial intelligence, has an application in manufacturing. It's not as widespread as we would like. So how will Hammer expand AI's role in U.S. manufacturing?
Yeah, thanks. So AI is absolutely crucial to where we're going with all of this. So right now, there's a lot of these things I mentioned. What a autonomous blacksmith might do, a robotic blacksmith might be able to do. Well, that's really something that requires a lot of intelligence on its own and responding to what the blacksmith would see in the metal or see happening. That's something where artificial intelligence can and should step in to actually correct the path as you end up going, as you're moving along. And this is something that's happening already. Companies like Path Robotics here in Columbus that came out of Case Western, they're a group that's looking at autonomous, artificial intelligence-inspired welding, where you can put a welding problem in front of a robot. It figures out how to do that, do the detailed path planning. If you actually have the skill of a welder, it's a very sophisticated thing, keeping the weld pool just right. You have to change the way you stir the pool, the distance, the angle that you hold things, and it takes years to learn that. But the beauty of AI is once one system learns it, that can be transferred to a different system, much the way a skilled welder might be able to go from one system to another. So that detailed control is part of what needs to happen with AI. At the higher level, there's also the concurrent design of the process and the component at the same time. So if you are going to make something, there isn't really just one way to solve a problem. We all know this. And so sequencing and designing how you bring those manufacturing processes together that might vary from place to place and time to time is another place that AI can play a really strong role. So there's at least two strong roles for that. And of course, as you know better than I, we have an awesome team of AI people here at Ohio State, and that's been part of some great strategic investments, and we want to lean into all of that.
So you talked about forging, casting, welding, human-to-robot transfer of skills. These are all technology-based concepts.
Exactly.
But we also know that technology can only do so much. And I'm saying this as an engineer. And so you really do also need the talent to apply it and continue to advance it. So thinking about this, how will you and your collaborators ensure that a skilled and robust workforce will be ready to staff this new age of hybrid autonomous manufacturing?
Right, you bet. No, that's super important. So one of the other parts of what happened where we had all of this offshoring and outsourcing and trade deficit is we don't have the people and infrastructure. We've got to build that up. So the size of the pipeline has to be much bigger. We've got to get into the high schools and earlier and let kids know that there are great jobs, great careers in manufacturing. It's not the same kind of career that it was. That's part of what we're going to do. The second thing is give people in-demand skills that have a real future to them. And that's something that we want to lean into, what I call liberal STEM skills, giving people STEM skills that can go into multiple industries. That's what we do here in engineering. And then we have these other programs like the Bachelor's of Science in Engineering Technology program is an important thing to lean into. And we'll also be really working with other organizations to train their trainers. So we're working with like the ASM Materials Education Foundation, hold a materials camp for teachers here this summer. We're going to be doing that. And we want to get teachers the skills they need to increase the size and diversity of the pipeline as well. We need really all hands on deck with this. And we want to show that there are great careers here and then give those skills and hit really the critical limits in it, which are really having enough great instructors out there that have this modern knowledge. And that's something we'll give in a number of ways, short courses, camps, all of that.
So basically the two, one is train the trainers so that they can give away and teach the next generation, and also that manufacturing is no longer your great-grandmother's job.
It's a great career. It's lots of creativity involved. It's not dingy and dirty, but it is a real technology working with robots, computers, all of that, and needs a broad skill set. And the other thing that's kind of changed, back in the day, it used to be kind of male-dominated because I think you were carrying big dies around and doing all of these things that sometimes resembled weightlifting. It no longer is like that. The heavy lifting and all of that is gone. It really is a minds on, but still hands on, high touch kind of environment. So it should bring in a different cohort of people, and we want to really enable that as best we can.
So following up on this theme of a Midwestern manufacturing revival, my question to you then is, why Ohio State? What is it about Ohio State that made the National Science Foundation say, this is going to happen and Ohio State is going to lead this engineering research center?
So before I say that, what I want to do is give a little love to our partners. We've got great partners in all of this as well. So again, we're working with Northwestern University, University of Tennessee, Knoxville, Case Western University, North Carolina, A&T. All of them great schools. They all bring wonderful skills to all of this, and we couldn't have done it without that group. But Ohio State is in an awesome position to do this. We have, again, material science is sort of the core of this. We're watching how the material evolves, and the robots are doing that. So that's part of the core. That's where I come from. We're bringing in all of this great work we were doing with AI and robotics. That's another piece of it. Another piece is the great land grant heritage that we have. And we're also situated really in the richest area in the world for this kind of thing. Situated here between what's going on in Detroit, building automobiles, shipyards, all those kinds of things. We are absolutely in the right place to do this. So Ohio State has the right ingredients, has the right location, and the land grant ethic that we have here is absolutely part of it too. We're here to serve, here to create the next generation of talent and jobs, and that's what it's all about.
As you said, the right set of partners as well.
And the right set of partners as well. I couldn't have done it without our partner institutions for sure.
So if people want to know more, how can they find out?
So there's a couple different ways. So we have a website at hammer.osu.edu. That's where everything is there. And then every Thursday we have Hammer Time, 4 p.m. It's Zoomcast. It's live. Sometimes it happens live at the Steam Factory. It did last week as well. And everything is going to be recorded and is on the web too. So people are encouraged to join that. And then also memberships are available at very low cost for individuals, companies, large and small. And details will be on the website as well.
So I'm really excited. Hammer is advancing national goals to assert leadership in manufacturing through the development of new processes and technologies, educating and preparing a robust workforce, and localizing supply chains through intelligent, autonomous manufacturing systems. And this is just the beginning. Thank you, Glenn. I can't wait to see what the future holds for Hammer as we pound it away. Okay, can you say, it's Hammer time?
It's Hammer time.
So you heard it here. If you like what you heard and are interested in learning more or suggesting your own topics for Enginuity, be sure to connect with us on Twitter at OSU Engineering. Thanks for listening.